If a squared plus b squared plus c squared plus d squared is equal to 1, all of those variables are real numbers. We want to show this inequality. We have a sum of to the fourth power. All of them are positive, less than equal to 6. So the pattern is that for those three terms, we fix a, we say b, c, d. And for those two terms, we fix b, then c, d. With this term, we fix c, then d. So I want to somehow create another expression, just change the plus into minus, and then come up with everything else is the same. We add them up and see what they add up to. So first of all, I say a minus b to the fourth plus a minus c to the fourth plus a minus d to the fourth plus next is b minus c to the fourth plus b minus d to the fourth plus c minus d to the fourth. Now, that should be equal to, so I'm looking at, so let's call this equation 2, call that equation 1. So this whole expression, equation 1. Right? Equation 1 plus equation 2, what do they add up to? First of all, I'm looking at this term, a plus b to the fourth. So a plus b to the fourth should be equal to a plus b to the square equal a squared plus b squared plus 2ab squared. A squared plus b squared plus 4a squared b squared plus twice of this multiplied by that. That is 4ab times a squared plus b squared. Right? So then I'm looking at a minus b to the fourth. Right? So this term. Everything else is the same. The only difference is that here I have a plus, there I have a minus. So according to the same logic, I should have exactly everything else the same, except I have a minus here, right, a minus here, and then minus there. Everything else is the same. So a squared plus b squared plus 4 a squared b squared minus 4ab a squared plus b squared. Yes. So what do they add up to? Huh? So they just cancel out, right? So twice of that plus 8 times that. So in fact, a plus b to the power 4 plus a minus b to the power 4 equals twice of a squared plus b squared quantity squared and plus 8 times a squared b squared and nothing else. Yes. So according to the same logic, okay, so let me just 2 times a to the 4 plus b to the 4 plus 2 times a squared b squared. I further expand that plus 8 a squared b squared. That is equal to 2 times a to the 4th plus 2 times b to the 4th plus 4 times that plus 8 times that. That is 12 times a squared b squared. Okay. So according to the same logic, we can further work out the sum of this term plus that term. The only difference is here's AB, here's AC, right? AB, we just say AC, right? Same expression. So here I have A plus C to the 4th plus A minus C to the 4th equals same pattern. 2 a to the fourth plus 2c to the fourth plus 12 a squared c squared. And also this term plus this term, so a d plus a minus d, same logic, 2 a to the fourth plus 2 d to the fourth plus 12 a squared d squared. Right? And so this term. So b plus c, b minus c equals 2b4 plus 2 c4 plus 12 b2c2. And also b plus d, b minus d, so b plus d, b minus d, 2b4 plus 2 d4 plus 12 b2 d2. And finally c plus d, c minus d, so c plus d, c minus d equal 2 times c4 plus 2 times d4 plus 12 c squared d squared. Right? So when we add them all up, right? So this whole expression plus that whole expression. Okay, what do they add up to? First of all, let's look at a to the fourth term. So this, and that. I got 3 of them, right? 3. So 3 times 6 times a to the fourth. So equation 1 plus equation 2 equals 6 times a to the fourth. And likewise, b to the fourth, right? Here, 2 times b to the fourth, 2 times b to the fourth. And also, likewise, 6. So 6 as a common factor, so b to the fourth. Likewise, c to the fourth, d to the fourth, right? All of them has a coefficient of 6. So, and now we have what? We have, look at the square times square term. So 12. So 12 common factor. Okay? And so a squared, b squared, a squared, c squared, equals squared. Okay, so a squared, b squared, a squared, c squared, a squared, d squared, and b squared, c squared, b squared, d squared, finally c squared, d squared. And common factors 6 and 12, that's also 6. So here I have just 2 and bracket, and outside here another bracket. Now the question is, can we further factorize that? And so let's look at the a squared plus b squared plus c squared plus d squared quantity squared. That is a squared plus b squared plus c squared plus d squared times a squared plus b squared plus c squared plus d squared. And that is a to the fourth plus this distribute onto that. So a squared b squared, a squared c squared, a squared d squared. And also this distribute onto that. So b squared a squared b squared b squared b to the fourth b squared c squared b squared d squared. Also this distribution, so c squared a squared c squared b squared c to the fourth c squared d squared. And finally this, so d squared a squared d squared b squared d squared c squared d squared d to the fourth. Yeah. Okay. So let's look at this a to the fourth, b to the fourth, c to the fourth, d to the fourth. A to the fourth, b to the fourth, c to the fourth, d to the fourth. Yes. So then we look at this term, a squared b squared. So a squared b squared b squared a squared. I got twice of them. Right, so in fact so this is already twice of that. Right? And also a squared c squared a squared c squared c squared a squared, right, twice. And a squared d squared a squared d squared b squared a squared, twice of that, right? B squared c squared b squared c squared c squared b squared, also twice of that. B squared d squared b squared d squared d squared b squared, right? Twice of that. C squared d squared, what is that? C squared d squared d squared c squared, exactly twice of that. So including that, right? A fourth plus b plus c to plus d, exactly. Right? The only difference is that here I times 6, there I don't have times 6. So that means this is equal to 6 times that. Right? So in fact, so the sum of this equation and that expression equals 6 times the perfect square. Alright, so this is fine. So then what do I want to prove? I'm going to prove expression 1 is no larger than 6. Right? And also, given that the sum of the squares is 1, right? Then I want to prove that expression 1 is no larger than 6. Is it true? Right? But first I know that equation 2 is what? Equation 2 is the sum of the fourth power, right? They're all real numbers, so this must be positive, right? Non-negative. So some expression plus a non-negative expression equals exactly 6. So that tells me that the other expression cannot be bigger than 6, right? Okay, if it's bigger than 6, then some number bigger than 6 plus a non-negative number definitely going to exceed 6. No way. There's no, so expression 1 has to be no larger than 6.